by Eric Hall at a conference for the scientific committee in Washington DC last year, and this was shown as one of the exhibits of substance of artificial intelligence almost 2 decades ago. Okay, so now that is the first innovation. Now let me move on to the next one, and this is about fusion. And once again, you can see, just like in the dynamic lexicon case, I'm sure many of you can think of a whole bunch of application scenarios where that strategy could work. Fusion also is essentially about taking different expert opinions and coming up with a single final decision. So I could have a case where, if going back to the lexicon example, if I have 10 words in my lexicon, my first recognizer approach puts it to maybe a small percentage of what I started with. And then that small lexicon can then be fed to another recognizer and reduce further. So the questions that can be asked are, what is the best reduction each recognizer should take? Because clearly when the lexicon size reduces, our accuracy will increase. However, we also know that if the successive recognizers are looking at the same features, then just reduction of the size of the lexicon is not going to help, because the subsequent recognizers are going to face a denser lexicon. Lexicon entries will look very similar. So there are a whole bunch of research questions that need to be addressed. For example, I could have 2 lexicons of the same type, both have 5 words in them. So in the first case, they all are 2 letters twice, this is a made-up example. In the second case, they have varying length. So if word length is one of the features, then clearly lexicon 1 is very, very dense. And lexicon 2, word length can be used as a feature to discriminate. So there is a connection between the density of the lexicon, the features that the classifier or the recognizer is using, and we have looked at various methods to come up with the best strategy in combining recognizers. So it's possible that different groups develop different recognizers, some of the features that they use overlap, others are different, and so every case has to be dealt with separately over here, where you figure out what this recognizer should go first in the pipeline, which should go later, how should the reductions take place, and so on, and we have published in that area. Now also what we did, and this goes to the medical domain, and I'm sure you can relate to this is from a medical form. I have extracted word snippets, and all these are examples of the word chest pain has been taken from medical form. Now let us say I don't have a lexicon, and I have a form with medical terms in it. What can I do? So we came up with a method of bootstrapping, where we said, okay, just try to recognize some letters in the word. So you can see that in the right side, the blue shows the correctly recognized and the red shows incorrectly recognized. And then we can bootstrap. So we can estimate the position of that letter in the word. In some context, go and look up a medical dictionary. So if this is the group of circulatory cardiovascular system, I can then look up words and figure out what is written. So we were able to do this with a whole bunch of medical categories, and I'm not sure if we can see those categories over here, and we were able to come up with lexicons for all of them. And then using the bootstrapping, we were able to get about 8 to 10% jump in our recognition rates. This was an application for medical forms, and here are some examples. This is a box of medicine prescription. If I just had to read without knowing that this is the medical term or the name of the medicine, I'm not sure I could read any of these. But notice that we have actually recognized, on the right side the results are shown, using the bootstrapping and a dynamic reading lexicon. We were able to recognize the first word as glycuride, in the second case corticosterol, and in the last case is the metoprolol. And this is possible, and look at the power of the lexicon over here, that not so carefully written medical term, name of the medicine name, has a better size accuracy. So that opens up a whole bunch of applications for us in the medical domain as well. Now, if it was a more engineering-based technical audience, I would have discussed the approach we take for combining different recognizers. So if I have lexicons and each entry is listed 1 to n, and I have recognition methods C1 to Cn, each recognition method independently sorts the lexicon based on how well it matches an image, and returns the score of the confidence it has in that particular match. So every recognizer or a classifier comes back with a vector of the lexicon entries rearranged in the way they have been scored. The task of fusion then is to derive the function f, which in the best possible way takes these 9 score column vectors, these 10 score column vectors, combines them somehow, and returns a single vector. Okay, so that essentially is the task of fusion. So a learning-based approach would be to learn that function f. Previously, heuristic approaches have been used, where you basically take an average, or just add them up, or take the highest, and so on. But none of them are optimal. Clearly, you need to come to the function that can be learned. And we have developed techniques of learning that function. Now, there are, in this classification task, I'm sure you must have figured this out, there are 2 ways in which you can approach the problem. One is, I ask you to verify a particular answer. So I give you a word image, and you just ask the question, is this particular entry? So that's called the verification task. Or you do not do any of those, you simply ask me to recognize what is written, and that's the identification task. Now here is how the 2 tasks play out. We are doing verification all the time when you are logging in onto our computer, right? We do you give our username, so there is a password that is already stored, you get across that username. So when I type my password, it matches only against what is stored against that username. This is verification. On the other hand, if you say, I'm not going to give you a username, I simply am going to give you a code and tell you who it is, that is the identification task. So not going into the back, let me just say here, so that we have come up with the optimal function f for the verification task, which has been shown to be the likelihood ratio. And for the identification task, we have said that a closed form solution does not exist, and what you need is an isolated method. So I'll skip the details are actually mentioned. course, the verification task, as I said, the likelihood ratio works out to be very, very good, and in other cases, it is an alternative method. We also show that the same approach of likelihood ratio, in fact, can hurt the solution if you use it in the identification task. Again, I don't want to get into the details, but it could even perform worse than the single recognizer. So here in the table below you can see C1 and C2 on their own can do 55% and 77%, and the likelihood ratio does 69%. So it is poorer than C2. So this can happen, and so that's what our paper is about. And we believe tremendous impact in talking about what method of fusion should be used when combining different recognizers. But again, I'll leave the details from the paper. And I'll move on. These are very theoretical results on how you take the scores from all the classifiers and combine them. Let me move now to the third innovation, and I can see that I have about 10 minutes left. So the third innovation is on indexing and retrieval. And here what we did was, we looked at historical documents, and I showed that in the medical domain there are many documents which have degraded, the legacy documents have degraded, and they need something enhanced, and even if I don't recognize automatically, maybe I can